Welcome, everyone. My name is Glen Burridge. As you don't know me, and I'm the Executive Director of the European Federation of Geologists. I'm going to be the host for this webinar. The European Federation of Geologists is periodically organizing webinars to foster the professional development of our fellow geologists and to increase public awareness of the importance of geoscience, something I know a lot of you care a great deal about. And today I have the great pleasure to present Sousa, who is going to tell us about the treasures of the earth. She is the Portuguese Association of Geologists Executive Director. And crucially for this presentation, it's important to know that she is the coordinator of our panel of experts on geological heritage. He is one of the delegates to our governing council, one of our Portuguese representatives. She's a Eurogeologist, and fun fact, she's a drummer in a progressive metal band, not preoccupied with all her geology activities. Her early interest in natural sciences made her choose a graduate study in geology. She holds an MSc in geological resources and a recently acquired PhD in geosciences from the University of Porto. Her study area is behind her. You can see it right now. And she's worked as a geologist at the Metro de Porto and the Porto municipality. She also develops training courses for geoscience teachers, and she's a member of the Institute of Earth Sciences in Portugal. She has a special interest in mineralogy, petrology, geochemistry, geochronology, structural geology, geohazards, and the subject of this talk, geological heritage and geoconservation. She is absolutely one of our most active members of the EFG community. She's promoted numerous outreach activities, and she promotes geoheritage almost every day, and geology's role in society. From 2010 to 2020, she was a member of the APG's board commission. So during Monica's presentation, we invite you, as with all webinars, to pose questions to her using the Q&A function and not the chat, the Q&A you see at the bottom of your screen. And we'll select some of these questions for a nice interactive session at the end after Monica's. So Monica, it's all yours.
Hi, Glenn. Thank you very much for your presentation. It's really a pleasure for me to be with you and with the EFG community this morning. I would like to thank you for inviting me for this webinar. And today I bring you the treasures of Earth. And we are going on a quest for some of the world's most iconic geoheritage sites. So Earth is, as you know, a planet with a complex and diversified geological history. During 4.6 billion years, plate tectonics, changing climates, catastrophic events, life explosion, and extinctions all transformed our Mother Earth into the changing planet that we call home. All these events are responsible for Earth's extremely complex geology and geomorphology, and thus for its geodiversity. And geodiversity refers to the variety of topographies, geological materials, and physical processes that societies have exploited for millennia and to their benefits. The World Geological Map shows us the great geodiversity of our planet that is reflected in its amazing and different landforms, landscapes, and that we can admire, in the geological resources that we can use, and in the physical process and geological phenomena that we may witness and learn through the geological record. No other solar system body is similar to the Earth's geodiversity, and this geological diversity can be explained by plate tectonics that is absent on all other planets of the solar system, except some recent episodes on Mars, climate differentiation in time and space related to the diversity of physical processes, sediments, and landscapes, and evolution, creating diversity in the geological record. Geodiversity supports life on Earth, and thus it has a great influence on biodiversity and its evolution. It is its silent partner. Only when certain abiotic conditions are available can life thrive. It is probably no coincidence that Earth, being the most geodiverse known body in the solar system, is also the one where complex life has developed. From microscopic to macroscopic life, geodiversity is always present. Throughout history, as we see also in these pictures, human societies benefited and continue to benefit from this geological diversity. The use of geological resources was key for the development of society and its cultural expressions. In fact, the designation of the stone, the bronze, copper, and iron ages for some of the historical periods is an example of how geological resources have an extraordinary role in human civilization through time. Empires and civilizations have expanded their territories in search for natural resources, many of them of geological origin, and have also demonstrated their grandeur in using those resources. Portuguese and Spanish discoveries, for instance, were also boosted by the demand and trade of those resources like gold. And the several industrial revolutions were also made possible due to the availability and exploitation of georesources. So geodiversity is also present in monuments, in our cities, and in the objects that we use every day. Many landscapes, geological phenomena, fossil locations have always attracted tourists, artists, explorers for their aesthetic, cultural, spiritual values, and artistic inspiration. Who remembers the Icelandic volcano that started its eruption in March of 2021, and then again in August this summer, attracting many visitors, being photographed and filmed on a daily basis, and being in the center of many excursions to Iceland. Some also called it the Mordor-like landscape. Another volcano that has drawn our attention last year was Cumbre Vieja in La Palma, Spain. So geodiversity is the reflection of the geological phenomena that drastically modify our planet and its landscapes, and that may cause a dramatic impact in the life of populations and living beings. Although its impact may be one of destruction, new environments and landscapes are also created, thus enabling the emergence of life and new opportunities for us humans. Geodiversity influences the landscape development, biodiversity, social development, leisure, well-being, sense of place, and inspiration. So even if it goes unnoticed, society assigns it a value. So what are the values of geodiversity? The values of geodiversity can be referred to as geosystem services, the geological equivalent of the ecosystem services used by ecologists. And it can be divided in regulating services like atmospheric and oceanic processes, terrestrial processes, flood regulation, and water quality regulation. They can be divided in supporting services like soil processes, weathering, soil profile development, habitat provision, land and water as platforms for human activity, burial and storage, for instance, municipal landfills, radioactive waste, carbon capture and storage. Provision and services, and here we can have food and drink, nutrients and minerals for health growth, energy, one of the big things in the moment, construction materials, industrial minerals, ornamental products, and fossils for sale. Also cultural services like environmental quality and, for instance, therapeutic landscapes for health and well-being, geotourism and leisure, cultural, spiritual, and historic associations, artistic inspiration, and social development. And the last one, knowledge services, Earth history, as we can understand the evolution of life, the extinction of life, the origin of topography of past environments, the history of research, environmental monitoring and forecasting, geoforensics, education, and employment. Although we cannot physically travel back in time to other geological eras or adventure ourselves on a Jules Verne-like journey to the center of the Earth, we can travel through time by reading the information preserved in rocks. Geologists are a kind of time travelers and rock detectives. By putting countless puzzle pieces together, we can reconstruct the geological history of the Earth and unravel ancient lost worlds. Let's see how. So this is a paleogeographic reconstruction by Esri, and it shows us the evolution of our planet from 550 million years to the present day. We geologists can also make predictions about the future. What would Earth be like 250 million years in the future? Let's see this new paleogeographic reconstruction from Chris Cortez. So we will have a Pangea Proxima in 250 million years. We will not be here, but we can make this kind of predictions by studying the geological records. Understanding the Earth dynamics and the information geodiversity gives us is of huge importance. Geologists can preciously help society to face several challenges like climate changes, geological hazards, energy transition, and sustainable development. In fact, geologies and geodiversity have a key role in the achievement of the 17 Sustainable Development Goals. The 17 Sustainable Development Goals, as part of the 2030 Agenda for Sustainable Development, provide a shared blueprint for peace and prosperity for people and planet. Adopted by all United Nations member states, the Sustainable Development Goals are an urgent call for action by all countries developed and developing in a global partnership. Although our society depends on geological resources to its development, there is also a need to preserve those parts of geodiversity that are important for reconstructing the Earth's history and the evolution of life on our planet. These parts of geodiversity that need to be preserved are defined as geoheritage or geological heritage. By conserving geoheritage, we are also preserving human history, allowing us to acknowledge and understand our place in the history of the planet. Implementing geoconservation measures on geoheritage sites prevents their destruction or damage and allows to preserve special places that are of scientific, cultural, and aesthetic importance and that play a crucial role in outreach, educational, and training purposes. This photo shows the ancient city of Pompeii, destroyed by the Vesuvio volcano at the back. Preserving this geosite is important to remember the history of the planets, but also the impact of the geological processes in our civilizations. Geosites are like pieces of a symphony, the symphony of the earth, and geoscientists are the earth musicians. There are two main international programs of relevance to geoconservation, World Heritage Sites and Global Geoparks. Both are promoted by UNESCO and being closely beneficial to society. The two maps that I'm now presenting identify a multiplicity of geological, natural, and cultural sites listed in these two international geoconservation programs. But these spots on the maps are not the only identified world sites with geological importance and in need for geoconservation. Each country has an important role in terms of geosite characterization and protection. Last October, during the International Union of Geological Scientists 60th anniversary celebration event in Zumaya, the first 100 EUGS geological heritage sites were presented, giving scientific recognition to those key geological sites for the Earth sciences research. So let's get to know some of them and sit back, relax, and enjoy our journey to the treasures of the Earth. Please be careful because we are entering a time portal. So I hope everyone is okay. We have traveled 4 billion years and arrived at the Archean zircons of Herewundu Hill. This geosite is like a window into the origins of the Earth. And here we can find the digital zircons with ages 4.4 to 4 billion years, preserving the oldest remnants of the Earth's primordial crust. So Herewundu Hill is the largest in situ repository of the oldest terrestrial crystals known to exist on Earth. It is one of the world's most important sites for ongoing research into the origin and evolution of the Earth. Using modern analogs, the sedimentary structures, grain sizes, and sequence of graded bedding and lithologies of the sandstone and conglomerates suggest the deposits formed in brain-dead river environments and fan deltas. As such, they provide a unique and important window to the processes and landscape of the Earth's surface in this part of the globe in very ancient times. So here is one of the photo of this geosite and a closer look to an Archean layered conglomerate of quartz pebbles in the sandry matrix, and the zircons that I'm talking about are within the quartz pebbles. The second stop is at the Paleoproterozoic hydroformation of the Quadrilato ferrífero. This is one of the most important records of Paleoproterozoic banded iron formation on Earth and place of ferruginous caves. The banded iron formation in the Quadrilato Ferrífero is a lake superior type iron deposit formed at the beginning of the Great Oxygenization event. During the Cenozoic, the wetter climate favored weathering that enriched iron minerals, producing economically significant iron ore bodies. So you can see in this first photo an aerial view of the Pico do Itabirito, formed by a compacted hematite monolith surrounded by an open pit iron ore mine. And in this second photo, we can see an outcrop of folded metamorphic banded iron formation in Serra da Piedade protected area. We are now at the Richat structure known as the Eye of Africa. This is a Cretaceous structure located in the Saharan desert and is a spectacular example of a magmatic concentric alkaline complex. So the Richat structure has been a case of scientific debate about its origin, if it is, and about the origin of the ring structures in the world. And there have been several studies to define whether if it is related to an impact structure or an intrusive feature. It is one of the most spectacular examples of magma-induced ring structures in the world. It is aesthetically beautiful and a unique geological feature whose outline is pronounced by the contrasting landscape of the wider Sahara. And in this second photo, we are just in the center, in the central section of the Richat structure. We fly now to the north to the Inuis-Landwin late Neoproterozoic Cambrian melange. This is a spectacular, accessible, and well-preserved exposures of late Neoproterozoic Cambrian melange with more than 200 years of geological study. Inuis-Landwin is globally significant as an historical reference site for melange and for testing geological paradigms on the formation of melange-type deposits. The more pillow lavas are globally significant as some of the oldest and best preserved. The site has a history of more than 200 years of geological research and has been used as critical evidence in numerous important regional and transcontinental geological syntheses and detailed studies. So in this photo, we are very close to these late Neoproterozoic Cambrian rocks that are exposed in the coastal sections and outcrops on Inuis-Landwin. We arrive at the glacial stratigraphic records of the Marinoan snowball earth from the upper Cryogenian to early Ediacarian. During snowball earth, ice sheets covered most continents, causing large sea level falls. This combined with thick shelf ice shifted sediment accumulations from continental shelves to slopes. Slopes were relatively narrow and the probability of fortuitous exposure 635 million years later is very low. Snowball Earths are rare, occupying only 1.5% of Earth history. Evidence of glaciated carbonate platforms is critical because due to saturation chemistry, they represent the warmest parts of the ocean. If they were glaciated, colder regions were frozen too. This was the first line of evidence for snowball Earth, much later supported by many independent lines of evidence. In this photo here, we see the abrupt contact between terminal ice raft carbonate debris, and post-glacial cap dolomites. And the second photo shows us ice-rafted dropstone in proglacial carbonate turbidites, illustrating impact structures. The Ediacaran fossil site of Mistaken Point is the best example on the world of an Ediacaran fossil community where life first got big. Mistaken Point was inscribed on the list of the World's Heritage as the best site in the world to witness the first complex communities of large metazoan life forms in the history of life on our planet. More than 10,000 fossil impressions ranging from a few centimeters to nearly 2 meters in length are readily visible for scientific study and supervised viewing along the coastline of Mistaken Point. So these fossils range in age from 580 to 560 million years and illustrate a critical watershed in the early history of life on Earth, the appearance of large biologically complex organisms, including the first ancestral animals. So here are a picture of some of the Ediacaran fossils at Mistaken Point. One of the world's best exposures of the Mohorovičić discontinuity is at Grosmorn National Park. Here we stand at the boundary between oceanic crust and mantle rocks, preserved at the Earth's surface in a dramatic glacial landscape. Grosmorn was inscribed on the list of the World's Heritage as an exceptional illustration of seldom seen plate tectonic process and of glacially modified coastal landscapes of deep fjords and tabletop highlands. It allows visitors to stand on the Moho, a boundary that is normally buried 5 to 70 kilometers beneath the Earth's surface. Grosmorn played a seminal role in the development of plate tectonics theory and the understanding of processes involved in building molten belts. So this is a close-up of structures produced during mid-ocean ridge deformation of automagmatic rocks. The most remote and currently least well-known of the Cambrian explosion sites is at Sirius Passet. It yields exceptionally preserved fossils. In this geosite, there are fossils of abundant and diverse fauna, dominated by arthropods with soft part preservation of gut contents, muscles, and nervous systems within a remote but accessible section. These fossils are preserved in the lower Cambrian strata. Most of the animals have not been transported and represent a living community in relatively deep water environments. The fauna provides a unique insight into some of the first complex ecosystems dominated by animals positioned in a more modern structure food chain. So on the left, we have very beautiful preserved stem group Trilobitomorph, Arthroaspis, and on the right, we have a pelagic predator, Isoxis. We arrive at the Namakdan Cambrian salt cave, one of the world's longest salt caves inside an amazing salt dome. It is 6,580 meters long and up to 40 meters wide, and it's considered the key geosite in Kesh Island UNESCO Global Geopark. The remnants of historical sulfur and salt mining and trading are among the cultural values of this site. Namakdan is also on the tentative list of the World Heritage Sites. For this reason, the cave is under strict protection and preservation. So here is one view of the Namakdan Salt Cave, and another view in the interior, one of the big holes of this great cave with untouched stalactites. Going out to Spain, at the Almaden syncline, we find a giant mercury deposit, the largest known mercury deposit in Earth, and with the longest productive history dating back to the 3rd century BC. This the exceptionality of this ore deposit lies in the unique geological characteristics that led to the high concentrations and large accumulations of mercury. The mining and metallurgical complex, together with part of the rest of the museum facilities, currently constitute the Almada Mining Park, which is open to the public since 2008. The park includes a visitor center, the Mining Interpretation Center, and the Mercury Museum. It offers tours in real tunnels in the 16th century inner mine. And Almaden is also included into the World Heritage List. So here in this second photo, we can see some cinnabar crystals from this mine. So we land at the Shilling Karst, the best site worldwide preserving and displaying various pineapple karst landforms. Don't get stuck on the spikes. Shilling Karst was formed during the Devonian to Permian and is a site of plateau karst, outstanding for the limestone pinnacles decorated with deep, sharp cairn, which is the result of karst processes. The limestone is overlain by red Paleogene sandstone and Permian basalt. Shilling exhibits pinnacle-shaped karst and other representative karst landforms like dolins, karst caves, depressions, etc., which not only enrich the aesthetic characteristic and values of karst in southern China, but also show the complex evolution history of karst landscape in southern China. So let's take a look at some of the pictures of this Shilling Karst. This is an aerial view, and this is another view from this pinnacle karst arising from a lake. We continue our journey to the Jurassic period at Sonhofen-Heistadt Archaeopteryx serial site. This is a first-class paleontological site displaying high-quality reference material for scientists worldwide, including all known specimens of Archaeopteryx. Due to the special sedimentation conditions, fossils from this geosite are exceptionally well preserved. So far, 12 specimens of Archaeopteryx are known, and all of them have been found in the area. Together with numerous other species described scientifically, this fossil is one of the world's most significant windows to the past. In the region, there are numerous quarries, some of them serving as official sites for visitors searching fossils. Several thematic hiking paths and several museums enable this geological heritage site to be experienced by local residents and visitors. And here we have one of the Eichstätt Archaeopteryx specimen found in 1951. This site is not only known for the filming of Game of Thrones. We are at the Cretaceous Paleogene stratigraphic section of Zumaya, one of the best exposed, most continuous and highly studied outcrops of deep marine sediments in the world. Zumaya section provides critical information about climate and biosphere evolution through critical intervals of geological time. The integrated biomagneto and cyclostratigraphic records help to reconstruct the Cretaceous Paleogene mass extinction and the impact of the Paleocene-Eocene thermal maximum, global warming in the oceans, and the subsequent recovery, and to define the global boundary stratotype section endpoints for the basis of the Selendian and Thanetian stages. The concentration of these major events marking key chronostratigraphic boundaries in a continuous section makes Zumaya one of the most studied and referentiated stratigraphic outcrops of the world. Zumaya is also a key location for study of deep marine trace fossils. From Zumaya, we climbed the time scale. We are now in the Quaternary, looking at the amazing Yellowstone volcanic and hydrothermal system. This volcano is well known for its past explosive eruptions and lava flows, as well as for its world-class hydrothermal system. The Yellowstone area fits most, if not all, the definitions and standards for all EUGS geological heritage sites. It is protected, with most of it within the Yellowstone National Park. It has world-class geological deposits that are accessible to over 4 million annual visitors. It is scientifically valuable to a host of disciplines, included but not obviously limited to tectonics, petrology, seismology, volcanology, mineralogy, geomorphology, biology, ecology, and medicine. Also, it is unique on Earth, hosting world-famous geysers such as Old Faithful and Steamboat. Given the dynamic nature of Yellowstone, it is a superb natural laboratory for biological, ecological, and geological processes. This first photo brings us the Silex Spring located in Lower Geyser Basin and is one of over 10,000 hydrothermal features in Yellowstone Park, which contains some of the highest concentrations of hydrothermal features in the world. And the second photo, very well known, is an aerial view of Grand Prismatic Spring, one of the largest hot springs in the world. Prepare yourself because we are going for a dive at the Sacto Antum underwater cave system. The extensive, this is the longest underwater cave system in the world. And these extensive cave systems under the Yucatan Peninsula have been a guardian of hidden and invaluable treasures to learn from our history. Remains of Pleistocene animals and humans that date from a time long before the occupation by the Mayan civilization have been found within submerged passages and galleries. Being underwater, these caves provide a unique environment for the preservation of human and animal remains linked to a fascinating and unique geological and geomorphological history. And they provide also evidence of the Holocene paleoclimate. This first photo is Evans Gates, one of the most popular places of the Cenote Nohok Na Chi, part of the Sac-Actum system. And this second photo is the Blue Abyss, an underwater shaft of 71 meters in depth, part of this system. From an underwater cave to the birth of an ocean. At the Danakil Reef Depression, we witnessed the ongoing birth of an ocean and the formation of new oceanic crust. We witnessed the impact of tectonics and volcanism in this extreme evaporite arid environment. The region is rich in several iconic and spectacular geological sites. Here we have the Hart Hill volcano with an active lava lake, and we can also see the Dalal geothermal area with unique important polyextreme environments like brines, active geysers, and other hydrothermal and saline systems, and several salt lakes. So despite being an extreme environment, the salt has been mined for centuries by traditional miners and continues to date. It is a major touristic destination that has, of course, geosites as attractions. The world here might seem upside down. This is where geomagnetic reverse polarity was first proposed through studying basalts. We are at the Gembudo Cave in Japan. Around 100 years ago, Motonori Matuyama first proposed geomagnetic reversal in Gembudo. This discovery greatly contributed to the subsequent advance of earth science. For example, ocean floor paleomagnetic stripes based on magnetic normal and reverse polarity intervals advanced the modeling of plate tectonics in the late 60s. Good exposures in Gembudo Park are quarries, work before the designation of the natural monument. Hexagonal discs of their columns of basalt were used for riverbanks, firewalks, and house fences. Such findings are useful for educational purposes. Let's now relax at one of the most famous spas in the world, at the Pumacali Travertines. This is a globally outstanding type site with a high diversity of travertine features and processes on active fault. The Pumacali Travertines are a key location for travitonics, embracing all aspects of travertine tectonics. This region includes 5 of 6 morphologies suggested for travertine deposits, accompanied with active faults. Studies by Iranian series method was key to relate the destruction of the ancient city of Hierapolis to these tectonic structures. The travertines reveal how seismicity affected the ancient Hellenistic to Byzantine civilizations and modern urban developments. Another geosite that shows the great effects of geological phenomena on humanity is the Quaternary Santorini caldera, one of the largest calderas in the Mediterranean Sea, formed by Plinian eruptions in a volcanic arc tectonic framework. The caldera is the result of one of the most destructive and the most famous of the eruptions that have impacted ancient civilizations, the iconic Minoa eruption, which occurred approximately 3,600 years before present. This eruption may have contributed to the fall of the great Minoan civilization, leaving its imprint on Greek mythology, archaeology, and volcanology in general. It is also outstanding that the stratigraphy of the volcanic rocks of multiple eruptive episodes is evident in the caldera walls. The entire area of the caldera features outstanding geological and natural characteristics, thus making it a living laboratory for earth sciences, volcanic risk monitoring, and study. The highest diversity of dune types is at the Namib-Sand Sea. The Namib-Sand Sea is an active geological, geomorphological phenomena that is a spectacular example of the evolution of a desert landscape. The Namib-Sand Sea, a UNESCO World Heritage Site since 2013, is a well-conserved part of the Namib Desert, offering a spectacular landscape formed by an interplay of geological, geomorphological, and atmospheric processes. Dunes of the Namib-Sand Sea, developed over an older dune system, exhibit the highest diversity of types and form an unparalleled Aeolian geomorphological landscape. The Namib-Sand Sea presents a spectacular and fascinating desert scenery with red-hued majestic sand dunes. So this photo here is a view from the International Space Station of the north-south linear dunes and star dunes along the Sousa River Valley. And in the second picture, we can see how fog is an essential source of moisture over the sandy dunes of this Namib-Sand Sea. We arrive at the end of our journey in a place also known for its destruction. The Nojima Fault is the one that caused the 1995 Kobe earthquake in Japan. Earthquake fault is a surface displacement that is important evidence of both the earthquake and the resulting disaster. The preservation of earthquake faults is extremely rare because they are soon flattened by landowners to recover their livelihoods, in addition to, of course, the difficulty in conservation techniques and management. Fortunately, immediately after the Kobe earthquake, the Nojima Fault was preserved for educational and research processes, and the topography and damage condition of this fault were preserved in the best way possible. As in Taiwan, the technique and management methods developed here have become the standard for fault conservation. This is another perspective of this fault. So we have traveled through time to some of Earth's iconic geosites. We witnessed the surge and perish of life, the formation of beautiful mineral deposits and geomorphological features, the birth and demise of oceans, ice ages, and impact of geological processes on Earth and on our civilizations. We had a glimpse of different worlds that are just waiting for us to visit them. Geoheritage is the Earth's geological legacy. These extraordinary capsules of times are treasures, and they preserve the memory of our planet, teaching us about the past and contributing to the awareness and understanding of the importance and multiple benefits of geodiversity for modern society and for the biodiversity of our planet. Each one of us must be the guardians of these treasures, preserving the extraordinary scientific, educational, cultural, and geotouristic values of geodiversity. Thank you. I hope I was not too long.
Well, you're giving a tour of the world through deep time. So that was fantastic, Monica. God, what an amazing journey. We do have time for some questions, so please put them in the Q&A. Just thank you so much for that, Monica. Wonderful. Sure that's made everyone's day to see those amazing sites and hear your commentary on them. While we're just waiting for people to post some questions, I mean, there's a couple that immediately come to my mind. Who would you most like to get this message across about geodiversity?
Well, first of all, of course, the governments, the politicians, because they are the ones who can really make a difference in terms of getting geodiversity and the profession of geology out there, and to make, of course, the public realize that geodiversity and geologists and geoscientists are important for our well-being and for getting the resources that we need for the energy transition, for having sustainable development that everyone talks about, but that, of course, many people or most of people do not think that geology can have a role in sustainable development. So, of course, the first ones would be those decision makers, those politicians who can really have a saying and can make the necessary changes. Of course, the other ones that we want to reach are the public, the audience, the ones that use resources every day, and simply and probably do not understand that they are using geological resources. They just, of course, are going on with their lives and not realizing that for the plates they are using, or for the glasses they are using, or for the smartphones or computers, they are using geological resources. And it is kind of a paradox that mining is not wanted, but resources are wanted somehow. So I think geosites and geoheritage is a portal for people to understand the importance of geology, to understand that the Earth throughout its geological history has undergone many changes, climate changes, sea level risings and fall, ice sheets covered the Earth, like we saw the snowball Earth, and of course that this is a way to show the different and the cyclic transformations that our planet has endured. And so this is the best door for them to understand that.
Wonderful, comprehensive answer to a big question.
Please let me just say that in the Google Earth visits, you may saw where I put the photographs and etc. All of those photographs and the text that are there is of course from the 100 EUGS geoheritage sites. So the copyright is there, and so this is of course I am not the author of all of these. I didn't study, of course, these geosites. I think it's very great thing what the UGS has achieved, and of course these are just the first 100 geosites, and I want to give them my congratulations for achieving this, and the credits are there and they are their own.
Wonderful. Thanks for pointing that out. I'm just having some trouble to find some questions in amongst all the compliments on your talk here. There are dozens of them. One question in amongst this is from Enin, I hope I've pronounced your name correctly, which is, how strong is the legal and societal protection of a site once it is labeled geoheritage?
Well, it might depend on the country. For instance, in geoparks, there is not a legal protection regarding those geosites. However, some countries, for instance, here in Portugal, we have several regulations and we have different kind of protections of the geosites. So we can have natural monuments, and let's say if that's a geosite is listed on the PDM, it's like the municipality map where they have all kinds of restrictions and where something can be constructed, where a building cannot be constructed. So if that is inscribed in that document, it is protected. So it depends on the countries, and it depends on the type of protection that it is offered for that geosite.
Question from DGP, and I hope that they're a policymaker. I don't know who DGP is, but let's hope that they're a policymaker. They've asked a wonderful question. Would you be able to use geodiversity as a driver or guideline towards the energy transition we are currently in? How does the geological knowledge, can it really save our planet?
Well, as we see, or as we saw in the presentation, we are using geological resources like geothermal in many ways. For instance, in Turkey, as we saw those travertine in Pamukkale, those spas, they are used for well-being for spa. But if you go to Azores or another locations also in Turkey, geothermal is being used for energy uses. So geothermal is, of course, not the only option, or not the only, how can you say, hypothesis. It's one of them. We have to think of several options, integrated options in terms of energy transition. We can not only think about, okay, let's go to geothermal, or let's go to lithium batteries, or let's go only to whatever. Let's forget about coal or forget about fossil fuels. This will not work, because we have to have an integrated use of all the energy resources that we have at our disposal. So we can use geothermal, we can use mining, we can use wind resources, we can use solar system resources. Maybe we will still have to use some fossil fuels and coal, but the point is that we really need to have an integrated option for energy transition. And of course, geothermal is one of the great options. It's always there. Earth is producing it, and we can use it with minor environmental impacts. And EFG is involved in several projects about geothermal resources. Yeah, and so the geological knowledge to knowing how were these systems working in the past can help us use them in the present and predict how it might work in the future.
We always love an advert for geothermal. Forgotten renewable. But yes, I mean, there's just about everything you can imagine that geology contributes to, and geodiversity is this wonderful basket that captures all that the Earth provides us. A question here from JG Gokula Krishnan: how can geology be introduced into schools in developing countries?
Well, it should. But I know that in not all of the countries we have geology in schools. Here in Portugal, for instance, there was a major step several years ago. We now have geology in the 7th grade, and also a little bit in the 8th grade, and in the secondary level school. Of course, we are thinking that it might need some adjustments because maybe the curriculum are not adjusted to the maturity of the students, mainly the little ones, the 7th grade ones. However, it was a huge step, and we can see some. I should be more optimistic about it, because we are still talking about people don't understand that they use geological resources every day. So, and we see it in Portugal. So if we have geology in school, why this still is going on? Why didn't we have a change in the mentalities of the students now, probably grown-ups? I think there are a lot of misinformation and misunderstandings that need to be resolved, and probably, I don't know if that happens in your countries, but in Portugal now things are changing. But some years ago, if something happens, a geological event happened, media would not call, for instance, a geologist. They would call a geographer or another professional, whatever. So despite we have geology in schools, I think that we need to look specifically to what kind of subjects do we want our students on that particular levels to learn, so that they won't be scared about geology, because geology is an abstract science, and you have to have maturity to understand some of very complex concepts. And for 7th graders, thinking about those processes in an abstract way may be difficult, so we have to look at it. However, I think it's really important to do that. And in Portugal, there was to introduce this curricula in the basic and secondary schools was really a huge effort of some of my colleagues that were working with the Ministry of Education, and that successfully introduced the geology in high school.
It's a very familiar story, isn't it? We've heard this from other nations within Europe, that this is a big battle that needs to be done at the national level usually. But we certainly have some stories about that. The other thing worth saying for developing countries is that in the day and age we live in now, there is an absolute wealth of educational material online. So that may be a specific way to get geology in front of students in developing countries in a way that maybe wasn't possible a generation ago. So the upside, you could say, there's plenty of stuff. But yeah, in terms of the curriculum, it's tough, isn't it? We have run out of time, unfortunately. But if you want to get in touch with Monica, you can find her on LinkedIn. And this webinar will be put online very soon with her presentation by the EFG team. I want to thank you all for participating, for your questions and your compliments to Monica. It's been great to have you with us. And just to put another out for our next webinar, which will be on the 26th of January, This will be about nature-based solutions of vegetation as a remedial measure against erosion and shallow landslides. So join us for that. These webinars are going to come thick and fast through the winter. Wonderful to have you with us. And thank you, and see you soon.
See you soon. Bye-bye.